Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. So what did we discuss yesterday? We discussed about the how to know whether a given reaction will follow SN1 mechanism or SN2 mechanism. Careful study of different SN1 and SN2 mechanism, whether a given reaction will follow SN1 or SN2 mechanism depend on following four factors. Number first, the effect of structure of substrate, and that we have described fully. There are two main factors again, sub-factor which will which will decide whether the following reaction goes or follows via SN1 mechanism or the SN2 mechanism. With the graphical representation, some of the tabulated form of the table we have seen, and by inspection of that table and the nature as that we already describe what type of the reaction follows SN1 reaction or the SN2, how to recognize it, whether the following reaction follows SN1 or SN2 by just observing the structure of the substrate. If the structure of the substrate is a primary alkyl halide, then that type of the reaction mainly undergoes via SN2 mechanism. If the substrates are very bulky or generally the tertiary alkyl halide, they mainly undergoes as a SN1 reaction, and that is depend upon the steric hindrance that we have decided. We come to know that what type of the reaction they are. And second factor we learned, what is that? Second one is the stability of the carbocation or stability of the positive charge. If the stability of the positive charge goes on increasing, the SN1 reaction goes on increasing, and if it is goes on decreasing, then the rate of SN2 reaction goes on increasing. That we have discussed so far. Now let us look at the second factor, which also decided from knowing the nature of living group, what type of the living group, and from that we can easily find out what type of the reaction is whether it is a SN1 mechanism or SN2 mechanism. And this is the effect of living group or the effect of nature of living group. This is the point we are now discussing here. Remember, and as we know that while studying the SN1 reaction and SN2 reaction, the living group, the careful study of these reaction, what do you observe there? The living group, as we know that the alkyl group is not the general reaction we have considered here, RBr, right? This substrate has two parts. One is a alkyl part and second one is a living group. And we know that the departure of living group takes place or occur, or the breaking of bond between carbon and the living group takes place in a rate determining step. Rate determining step, RDS means rate determining step, and therefore the nature of living group decided the what type of the reaction it is, whether it is a SN1 reaction or the SN2 reaction. So that is both get affected on the basis of living group, and therefore the good living group is found to be a conjugate base of a strong acid. And first one, there are, let us consider some of the example over here, the good living groups. Let us see here. Suppose we have this type of the groups are there. First one, among the halides, as we know that halides, amongst the halides, the living group stability decreases. The living group stability decreases as, for example, I is a more better, as we know that halogen family member, fluorine, chlorine, bromine, iodine and astatine. Don't think about astatine, but this is a iodine, then bromine, then next one is a chlorine and then fluorine. Look at amongst the halide, the living group stability decreases. Why it decreases as like this? If you go from left hand side to right hand side, what do you see? There is a decrease in the stability of the living group. It means here iodine has a greater stability. It can departs very easily, or the bond breaking, the energy required to break the bond between carbon and the iodine is a minimum, and therefore it departs easily, and it is a good living group, as well as it is a good nucleophile also. Let us look at as one of the reaction over here. Among the halide, the living group stability of decreases iodine, and what do you see over here? They are the I minus, or let us see here, HI, then HBr, SCl and the HF, right? Then hydrogen iodide, hydrogen bromide, hydrochloric acid, hydrogen fluoride. So these are the acids, because I minus here, I minus or Br minus, Cl minus, F minus, these are the conjugate bases of the strong acid. These are the strong acids are there. HI, HBr, SCl, HF, all are the strong acid. And as we know that living group stability just now we have seen. Or what about the nucleophile? Yeah, I minus is a good nucleophile than the fluorine, and fluoride F minus is a poor living group. Why it is a poor living group? Again, stability order of this nucleophile is this one, because they are the conjugate base of the strong acid. These are the sum of the strong acid. And now tell me which one is a more acidic in nature, whether HI is a more or HF is a more, because these are in between these two, hydrogen bromide and the hydrogen chloride. Now look at here, the acidity also decreases in the same manner, means HI is the strongest acid, then HBr, then HCl, then the HF, because here the energy required to break the bond between hydrogen and iodine is a very weak, minimum energy required for the dissociation of the H plus, and that's why I minus is a good nucleophile and it is the strongest acid. So in this way, let us see some of the reaction over here. Suppose A is there, RI, then that will be treated with water, right? And water get, and when it is added, this water is adding over here HBr, you are going to get the reaction formation of the alcohol, as well as here I minus you can call it, or HCl is formed. Here is a RCl, not, let us see here, make the correction small here. One of the reaction, first one, A is a RCl, then B is a R iodine, because we are comparing which one is a good living group. Here the nucleophile we are using as a water, we are adding as a water over here. Here also as a water. Now water added, here Cl get depart, so that we are getting alcohol ROH plus HCl, and in this case R iodine and plus ROH alcohol and plus HI. In this case, if you determine the rate of this reaction, what do you find? This reaction is a very slow reaction. This slow reaction, and this is a very fast reaction. Rate of reaction is a very fast here, slow reaction. This one is a slow reaction, this one is a fast reaction. And when it is a fast reaction, what it indicates? It is inferred here that this iodine is a good leaving group, because this is a nucleophile attacking on that R, and there is a departure of the iodine. The rate of reaction is very fast in this case. That clearly indicate that iodine is a good leaving group over the chlorine atom, and therefore this is a one more reaction. Now let us look at as another one. These iodine act as a good nucleophile as well as good leaving group. Let us see another example over here. Again we are comparing here the two reaction. Let us see one reaction is here RCl, then Ri over here. Now here we are adding as I minus in presence of potassium iodide. What do you get here? Iodine act as a good leaving group. There is a departure of chlorine atom. We are getting alkyl iodide, and then in this case if you add the water molecule here, again H2O, you are going to get ROH and plus HCl, not HCl, there is a HI. Now look at here, in the both case I minus act as a good nucleophile here. I minus act as good nucleophile, whereas in this second reaction this is acting as a I minus act as good leaving group. In a first case, in the first reaction, and look, if you observe these two reactions carefully, what do you see over here? Here I minus attacking on that R, there is a departure of chlorine, and we are going to get as a formation of here is a alkyl iodide, and the Cl is a leaving group. And here I minus act as a good nucleophile here, because nucleophile is nothing but it is attacking on the carbon atom, forming a new covalent bond. So that is the definition of that nucleophile, and therefore I minus act as a good nucleophile. Whereas in the second reaction, what do you see over here? Water as a nucleophile here is attacking, and so that iodine departs very easily, and we are going to get here formation of the alcohol. In the second reaction, I minus act as a good leaving group. So these are the two differences. From that we come to know that why that iodine is a good nucleophile as well as good leaving group. So both these things. Now let us move on to the second point we are going to discuss over here. Let us see that one, which point we are going to discuss over here. Second point, second one here, this is a second effect here. Let us see one, and there is a two. Second point we are going to discuss, OH and OR minus are bad leaving group. OH minus and OR minus are bad leaving group. Bad leaving group. OH minus and OR are a bad leaving group. Why this so? The groups OH and OR minus are found to be a extremely poor living group. These OH minus and OR minus, these are very poor living group because they are the conjugate acid of very weak acids. That is why this, let us see, for example, here suppose we have a ROH, right? ROH, this is one of the reaction that will be treated with Br minus here, and we are adding here sodium bromide, NaBr. Let us see one reaction over here. Second reaction, suppose ROH that will be treated with Br minus in presence of HBr. What is going to happen? Now look at here. Observe these two reactions carefully. One ROH Br minus, that is a nucleophile we are considering here. ROH alcohol and Br minus, again we are considering the nucleophile over here. Now what is going to happen in the first case? What do you think? Whether the reaction is going to take place or not? No, because here Na sodium bromide used as a salt over there, and therefore it is a very bad living group, and therefore no reaction. In this case there will be a no reaction. But in a second case, what is happening? We are adding catalytic amount of the acid over there, and therefore here the reaction will take place, and you are going to get RBr and plus H2O as a living group over here, and here fast reaction takes place. This one is a fast reaction takes place. Fast reaction takes place in the second case. Why in the second case fast reaction? Look at here. When we are adding catalytic amount of the acid, what is happening? Let us look at as a mechanism here. Why this one is happening? Now ROH that will be treated with first one HBr, right? Now what is happening here? This OH get protonated by picking that proton, and you are going to get here ROH2 and plus Br minus. Look at here, oxygen atom has a 3 bonds over there, therefore positive charge comes on that oxygen atom. And I already told you that whenever there is a positive charge on a more electronegative atom, that species become highly unstable. And now here the nucleophile is going to attack on that R, and there is a departure. Means here the living group is not the OH, the living group is a water here, and therefore we are going to get here RBr and plus H2 water. Remember, this is a, and here we are using as a catalytic amount of the acid over there, and so that this gives the reaction, whereas this alcohol do not give the reaction in presence of the sodium bromide. So that is the one thing you remember. And same trick is used to cleave the ether cleavage. Same trick is used over there. Let us see in case of suppose we have this one. Suppose we have alcohol, right? RO, then R dash that will be treated with R dash that will be treated with H plus or HI. Here is a H plus in presence of what we can call it as a hydrogen iodide. What is going to happen? This ether pick up the proton like this, and we will get RO, then R dash you can call it as for designation of, or what we can call it as the distinction of that R, and the another R is a different. Suppose let us see here H. Again look at oxygen atom. Oxygen atom has a 3 bond over here, 1, 2, 3. Therefore there will be a positive charge comes on that oxygen atom, and whenever oxygen atom any electronegative species carries a positive charge, they becomes highly unstable in nature, and now here is a nucleophile is going to attack on backside, and you are going to get the product Ri plus ROH. Alcohol is a back. So in this way we can the OH minus and OR are the bad leaving group, because in this case the OR minus is a bad. Here in this case OR is not the leaving group. Here is alcohol is a leaving group, because alcohol is a weak acid of the that strong bases. OR minus are there, strong bases, and therefore in this way. And now third point we are going to learn over here, OH minus group can be converted. Third point we are going, this is a very important as far as exam point of view is concerned. OH minus can be converted into better living group, better living group by first converting it into tosylate group, into a tosylate group, C double bond group, right? This is the OH minus can be converted into better living group by first converting it into a tosylate group. Now let us look at here the general ROH, right? Alcohol that will be treated with tosyl group, as we know that tosyl group is a Cl, then S double bond O, this one, this is a group CH-3, this is known as a para-toluene sulfonyl chloride, this is known as para-toluene sulfonyl chloride, sulfonyl chloride, or it is termed as a tosyl chloride. It is also known as tosyl chloride. And therefore what is going to happen, this lone pair which is present over there attacking on this, and we are departure of one H from here, Cl from here, and you are going to get here this type of the compound RO, then this what is that sulfonic group, C double bond O, then this benzene moiety, and then CH3, or in short we can write this ROTS, tosyl group. You can write either this way or this way. And now this one, this group becomes as a very good living group. Now even though weak nucleophile can attack on this nucleophile, suppose let us see here CH, or what we can call it MEC double bond O, here is a sodium acetate, sodium minus charge, positive charge, or sodium acetate is a weak nucleophile, is going to get or attack over ROTS, right? This negative charge attacking on that R, then OH, means we are going to get here R, then O, C double bond O, and Me. That is a ester we are getting here, ester, and the living group will be the O minus TS, right? Tosyl group, and that tosyl group is an excellent living group, because this is a stabilized, this tosyl group. Let us see over here how that tosyl group get, why it is an excellent living group. let us see over here, O minus, then S double bond O, then this group benzene para-toluene, it get resonate, negative charge coming here forming double bond, negative charge over there means O double bond S, O minus, and here double bond O, this benzene ring as it is CH-3 and etc you can write. So in this way it get resonance, means this is a excellent living group. Tosyl group is a excellent living group because it is a well stabilized due to the minus R effect of sulfonyl group, S double bond O group, and that's why 2 mark or 3 mark question may appear in your exam. Remember how the exam OH minus, how will you convert OH minus group into a good living group, So in this way you have to describe the OH group can be converted into a till better living group. First it is converting into as a tosylate group, because why it is a better living group or excellent living group, because whatever the quality of the living group, once it is departed, it should not recombine with the carbon atom. So that are the some of the criteria of the good living group. I think with this we have completed the what we can call it as the effect of living group, and from that we can easily find out the what type of the reactions are there. So whether it is a SN1 reaction or the SN2 reaction. I think with this let us stop today here. Have a nice day. Thank you.